So I think I'm actually going to try to do this fairly quickly if I can. It's a small project, so what I wanted to preface this with is that this is work that I'm doing with Flint University of Cincinnati. He's a zooarchaeologist, and the main interest of this work was that all of the samples that were used were actually clods of dirt recovered from excavated zooarchaeological samples from a few decades ago. So up front, I'd like to say that one of the intended methodological implications is that using FTIR and any other method, we can actually start to reconstruct stratigraphy and soil processes for materials where we actually may have lost that data due to excavation and whatnot. And the simple lesson is washing your artifacts isn't always a good thing. All right, so which part was okay. So for this for this project, we're focusing on the site of Nicoria. Let's see. It's been highlighted as a prime example for the popular theory that deep Greek Dark Age society was pastoral, in contrast to agricultural societies of the preceding Late Bronze Age and subsequent Archaic and Classical periods. Increase in cattle in the zooarchaeological samples of Dark Age Nicoria has been used to characterize the entire period as one of beef cattle ranching. This paper is attempting to disprove that using samples from recovered from bags of dirt and bones. So the settlement of Nicoria was identified and excavated in the 60s and 70s by the University of Minnesota. The ridge is located in the uplands of Messenia, east of Aguillon Mountain Range. None of this is particularly important. Identification of Nicoria in the Linear B tablets, the Greek archival record, was identified as a settlement of Timatoakai from Linear B, and it suggests that this was a site where there was some cattle ranching going on at some point in the Late Bronze Age, because there were ox hides, leather, being mentioned in the archival records. Surface survey and excavation of the area indicates that this rural settlement reaches peak size earlier in the late Bronze Age with the construction of numerous residences, particularly along the northeast-southwest orientation. Contrast between an absence of public infrastructure and one monumental tomb suggests that this is a site with some local leading craftsmen, but otherwise it's not a big site. It's also flourishing in the subsequent Dark Age of the early Iron Age, with a change of plan. The presence of local hierarchy again is suggested through Unit 4-1, which is this larger house with east-west orientation. All right, so the proportional increase in the cattle and Dark Age phases of Nicoria was initially reported by Sloan and Duncan in 1978. The counts are based on a calculation of the minimum number of individuals. They state that since cattle provide more meat, the contribution to the meat protein increases from about 40% to 63% in the Dark Ages. The pattern, in addition to a shift towards younger cattle, which they measured via analysis of the teeth, was later debunked in something like 1989. And this suggested to them that there was a change in husbandry from Bronze Age dairying to Dark Age beef ranching. They finally suggest that the Dark Age was a time of a high meat diet and low population. The initial conclusion, the cattle decreased in age and formed an oversized importance in the diet of Dark Age denizens, was highlighted by Anthony Snodgrass's model for Dark Age pastoralism. Won't quite go into Snodgrass, but essentially what Snodgrass was saying was that you had less people. They drastically changed the way that they're organizing sites, and they're moving towards pastoralism. And this gives us the colloquial term of Dark Age cowboys for Greece. So when my colleague Flint went back and looked at this data and looked at these bones, he noticed something particularly important, which was that when he went and he used a slightly different counting method, he was able to elucidate the fact that although there is a proportional increase in cattle, there seem to be more sheep and goat represented. And his question then becomes, is this a taphonomic, is this a preservation bias that is starting to occur? Because cattle bones are bigger. In particular, you have a higher occurrence of the denser cattle bones like the femur. And so what we want to do here is in particular start looking at the taphonomic assemblage, an understanding of the processes that changed the distribution of the skeletal elements in the soil column. And so first what we did is we went back and we actually looked at the state of preservation, looking at cracking and pitting in the bones. And what we do start to see is that for the dark ages, we get a larger number of poorly preserved samples. And mind you, if anyone's asking for sections and all this, remember I'm doing this on dirt that came out of a bag. So we have decent records of where things were found, but we're sort of working blind in a sense. Just an example of some of the poor states of preservation. I will say that these were the ones that were good enough to photograph. Frequently what we would get is bone splinters. Just bone that had little cohesive structure left to it. And this was very specific to the upper reaches of the soil. And so then when we go back and we look at what was done in the 60s and the 70s as far as the soil science, this is where I get comfortable. All that bone stuff was difficult for me. So what we see is that they did in fact find a particular change in the soil. They actually found the distinction between a B horizon and a C horizon that was quite distinct. So they recorded the B horizon as this dark, muddy soil, and then first they argued back and forth as to why it was dark and muddy, and so they said, oh, it's a B horizon. B horizon simply being the shallower area in a developed soil where the clays sort of start to reprecipitate and adhere to things. And then below that you have a C horizon, particularly a high carbonate C horizon. So the calcium carbonate is traveling slightly farther through the soil column and is collecting at lower levels. And what's important about that is that if this is true, this starts to give us something to test. Because as the leaching is occurring and things are being moved down column, you have a removal of calcium carbonate from the topsoil from the B horizon, and then the increased calcium carbonate precipitating down the C horizon acts as a buffer. And so the older material from the Bronze Age is down in the C horizon, and you can suggest that it's actually going to undergo less transformation because of soil formation, because of the percolation of rainwater through the soil column, and so it should be better preserved. So to test and to examine this, we took a bunch of clods of dirt from bags, and we impregnated them in resin. And we first looked at the micromorphology, and quite happily, what we did see is clay coatings on sand particles, which tells us that this is a B horizon for a soil. And then we saw a lot of calcium carbonate forming in the spaces between clasts for the lower levels. Just to show you again, as I said, in these upper levels, we have a lot of leaching. These are teeth with nothing but the outer layers of dentin and enamel left, completely hollowed. There are some cases where there was nothing but the very outermost layer of enamel left to the tooth. Dentin and enamel being the two hardest substances in the skeletal system. Wrong direction. All right, so using just standard transmission on the bench, we went to compare these against materials that we knew should be there. In particular, we were looking for calcite. When we were looking for characteristic peaks for calcite, what we are able to find is that in almost every dark age sample we weren't finding it, whereas in the late Bronze Age we saw a transition, so slightly higher up. Slightly lower down, and the lowermost, we more consistently found peaks relating to calcite. Now, if we move to apatite, so if we have bone dissolving in the soil column, you'd presume to find some free apatite transforming in the soil column. And again, as we look for the peaks, we see the inverse pattern occurring, where we have apatite occurring in the higher levels of the soil and not in the lower levels of the soil. So if we go and do some very simple percentages of this, we can illustrate that inverse relationship. And so all of this coming together, and just this was something small as that, and I still haven't worked out, I want to do more math, but looking at the peak splitting for the bones, if we look lower in the soil column, we see the bone is less split, whereas if we look higher in the column, so that the crystallinity index of the bone becoming more severe, I think this is something like a splitting factor of 3. I haven't done all the math because my free trial for FTIR analysis software ran out last week. But that was just something that's our next direction in looking at how all of these changes are happening. So I just wanted to give a simple illustration. You have your dark age surface with all of your bones, and you have the eons pass underneath with bones of varying sizes. Those are ribs and femurs, if anyone's a stickler for osteology. So we bury the dark age layer, and then we let some grass grow, and we got some rainfall, and what you get is clay enrichment down below the plants, and then calcium enrichment below, which results in the skewing of the taphonomic assemblage. Pretty self-explanatory. In the top, you have a less buffered environment, so you're more likely to lose the less robust bones. And in fact, when we went through, we did find that the cattle bones present are the robust cattle bones, like the femurs. The smaller cattle bones do in fact also disappear along with the sheep and goat bones. And so just moving on, we've started looking at other sites. Whether or not we'll get permission to look at material is one question, but what we have been able to do in looking at reports is show places, basically the other 3 well-studied zooarchaeological assemblages for these dark ages. Also, there is a marked poor preservation, specifically of the dark age bones. And so the whole point of this is simply to say that if you're going to make an assumption about society based off of a bone assemblage from one site, you should check your taphonomy first. Thank you.